Namaskaram. Welcome back. In this video today on the discussion of STEM, that is science, technology. So let us start with chemistry and metallurgy today. Indian metallurgists and material scientists were advanced in their understanding of metals, alloys, and crafting techniques, excelling in areas like iron, steel, copper, zinc, and gold production. These achievements are evidenced by historical artifacts, structures, and texts, many of which remain significant even today. The key achievements in metallurgy and material science in the ancient Indian knowledge system is iron and steel production. It's called crucible steel or Wood's steel. One of the most celebrated contributions of ancient India is the production of Wood's steel, a high-quality crucible steel that was renowned for its strength, durability, and ability to hold a sharp edge. This steel was used to craft swords and weapons, especially the famous Damascus steel swords, for which India was very famous, and it was traded across the Middle East and Europe as well. The process involved smelting iron ore with wood and other carbon sources in a crucible, creating a steel with a unique pattern of banding. The technology for making Wood's steel was highly advanced and guarded. The best example of Wood's steel is the Delhi Iron Pillar, which was supposed to be constructed in the 4th century Common Era. The Delhi Iron Pillar, erected during the Gupta period, approximately 4th century CE, is a marvel of ancient Indian metallurgy. Standing over 7 meters tall and weighing over 6 tons, the pillar is made of wrought iron and is very famous for its corrosion resistance, having withstood over 1600 years without significant rusting. This demonstrates the ancient Indian metallurgists' advanced understanding of iron extraction and processing, as well as surface treatments that inhibit corrosion, which remains an area of active research even today. The other key achievement in metallurgy and material science is zinc extraction and brass production. India was first civilization to develop the process of zinc extraction from its ores around the 1st millennium BCE. The Zawar mines in Rajasthan are evidence of the earliest large-scale production of zinc. Indian metallurgists perfected the distillation process to extract zinc from the ores, which was difficult because zinc vaporizes at relatively low temperatures and condenses back into solid material. This technique was later transmitted to China and Europe also. Prior to India's advancements, zinc was known only in the form of brass, which is an alloy of copper and zinc, which was used without understanding the process of zinc extraction. India also was famous for the brass production. Brass is an alloy of copper and zinc, which produced in ancient India by controlling the ratio of copper and zinc during the alloying process. Ancient Indian artisans were skilled in creating various grades of brass from different uses, such as crafting utensils, ornaments, and tools. Copper metallurgy is another key achievement in metallurgy and material science, which could be evidenced by looking at the Harappan civilization, going back to 2500 to 1900 before Common Era. The Indus Valley civilization, Harappa and Mohenjo-daro, demonstrated early evidence of copper metallurgy. Artifacts such as copper tools, seals, and ornaments have been found in excavations indicating a well-developed system of copper smelting and forging. Ancient Indian copper metallurgy also contributed to the development of bronze, an alloy of copper and tin. The production of bronze was critical to the Bronze Age, facilitating the crafting of tools, weapons, and sculptures. Gold and silver craftsmanship is a major key achievement in the metallurgy and material science of ancient Indian knowledge systems. India was a major center for gold and silver extraction and craftsmanship. Gold and silver ornaments, coins, and religious icons were produced using advanced metalworking techniques such as casting, forging, and embossing. Ancient texts such as the Arthashastra describe techniques for extracting and refining gold. India was well known for gold mining activities, particularly in the southern regions, and for being one of the largest producers of gold in the entire Asian world. Advanced alloys and artifacts are the important contributions of Indian knowledge systems under metallurgy and material science. The 5-metal alloy, which is commonly called as Panchaloha, is a sacred alloy made of 5 elements, usually with gold, silver, copper, iron, and zinc. This was commonly used for casting Hindu idols. This alloy was known for its durability, corrosion resistance, and religious significance. Panchaloha was used in temples and in crafting religious icons, particularly in South India, where idol making was highly developed in an advanced stage. You could see in the picture how beautiful the idols are. The other major contribution of advanced alloys and artifacts is the bronze sculptures, especially during the Chola period, extending from 9th century Common Era to 13th century Common Era. The Chola dynasty of South India was famous for producing exquisite bronze sculptures, particularly of Hindu deities such as Shiva and Nataraja. These bronze sculptures, made using the lost wax casting technique, exhibit not only artistic brilliance but also sophisticated metallurgical knowledge. The Rasaratna Samuchaya and Rasashastra are the important textual sources on metallurgy in the ancient India. These ancient Indian texts, especially Rasashastra and Rasaratna Samuchaya on alchemy and chemistry, describe detailed process of metal extraction, purification, and alloying. They also discuss the medicinal use of metals, indicating early advancements of chemical metallurgy and an understanding of the material properties of metals. Another important textual source of metallurgy is Arthashastra, written by Chanakya during the 4th century before Common Era. Authored by Kautilya or Chanakya, the Arthashastra includes sections on mining, metallurgy, and the management of mines. It outlines the state's role in regulating the production of metals and alloys, as well as organizing of guilds that oversaw the metallurgical work. The ancient Indian knowledge systems also had given a detailed study of mercury and alchemy, or the Rasashastra. And ancient Indian alchemists were skilled in working with mercury, using it for medicinal and metallurgical purposes. Rasashastra, a branch of alchemy, focused on the medicinal use of metals and minerals and also explored the transmutation of base metals into gold. The preparation of bhasmas, metallic ashes, for therapeutic use was one of the most advanced applications of metallurgy in ancient Indian medicine, as described in works like Rasaratna Samuchaya. Iron and metal weapons is one of the important contributions of ancient Indian knowledge systems to the entire world. India was known for producing high-quality iron weapons and armor. Indian swords made of wood stool are highly sought after by armies across the world due to their sharpness and strength. Sushruta Samhita, an ancient surgical text, mentions the use of sharp iron instruments in surgery, reflecting the understanding of high-quality metal tools for both medical and military purposes. India's achievements in metallurgy and material science had a far-reaching impact The technology of wood steel was transmitted to the Middle East and Europe, where it became the basis for the Damascus steel tradition. The extraction of zinc and the production of brass were adopted by other civilizations, including Chinese and later the Europeans. Indian alchemy, Rasa Shastra, influenced both Islamic alchemy and medieval European chemistry, particularly in the study of metals and their medicinal applications. So, in conclusion, we can say ancient India's expertise in metallurgy and material science, including chemistry, is evident in its contributions to the production of high quality metals, alloys, and artistic craftsmanship. From the sophisticated techniques of wood's steel production to the corrosion resistant Delhi iron pillar and advancements in zinc extraction, Indian metallurgists displayed profound knowledge that influenced global practices. These achievements demonstrate the scientific and technological brilliance of ancient India and its lasting influence on metallurgy across the world. Thank you very much for being a part of this beautiful video on chemistry and metallurgy. See you in the next video. Bye for now. Namaskaram.